Hello everyone, this is Ryan Hong and this is my ENME351 Lab 4, Sampling and Aliasing. To get us started, I'm going to be briefly going over my code. At the top of my code, I have my variables for the sample frequency, delay time, start time, and end time. Additionally, I have set my serial port speed to 115,200 bits per second. As you can see in the loop and setup function, I utilize the micros command and an if statement to create a timing function as opposed to using the delay microseconds command. My Arduino will continuously read the potentiometer values, which will then change the delay time and sample frequency. It will then print my channel 1 values to the serial monitor, where processing will be able to read that information. First, I will start by uploading this code to my Arduino. This is my circuit. I will rotate the potentiometer to change the sampling frequency. This is my end scope. Currently, you can see that I have a 4.75 voltage signal set at 75 Hz. I will now run my processing code to determine the alias frequency at various sample frequencies. Here are my 16 screenshots of the input frequencies at different sampling frequencies. Starting off, I will show you an input frequency of 75 Hz. Now an input frequency of 100 Hz. $215 and finally 300 Hz. Here is my data table. As you can see, the hypothetical and experimental values for alias frequency are quite similar. The values boxed in red demonstrate aliasing. Here are my calculations. We know that the Nyquist rate is 2 times the input frequency, and the Nyquist frequency is half of the sample frequency. Aliasing occurs when we were using a sample frequency less than twice the input. In that case, we would have to use a folding diagram to determine the alias frequency. I will show you my individual calculations for each input frequency. Please feel free to pause the video to take a closer look. My wires are no longer connected to the A1 output. As you can see, it is now connected to the P1 pulse output to generate a square wave. Here is my end scope. Currently, it is generating a 10 Hz square wave. On the VSA screen, you can see my sample rate is approximately 500 Hz. As you can see on my amplitude spectrum plot, there are harmonics present. So that means that the periodic signal can be written as a sum of multiple sines and cosine terms. My end scope is now outputting a triangular 4.75 voltage at a frequency of 10 Hz. There is an aliasing frequency as shown here. This is because the sample frequency is way less than twice the input. Looking at a side-by-side comparison of the triangle wave and the sinusoid spectrum plots, we can see that they are quite similar in comparison to the square wave, which had multiple harmonics. That was the end of my video. If you enjoyed it, please like and subscribe. Thank you and have a great day.